Today, we're gonna do a classic demonstration. We're gonna take a bar of ivory soap and turn it into a cloud of soap. For this demonstration, we're gonna only need a few things: a bar of ivory soap, a bowl of water, a knife, and a microwave. So what you're gonna wanna do is go ahead and unwrap your bar of ivory soap. Did anyone else use this as a kid? Me too. I was just informed if I cussed, this goes in my mouth like my mom did. Okay, so the tagline for ivory soap is, "It floats." So let's see if that's the case. I'm gonna put it on top of the water. Let's see. It does. It does float. You might notice that other bars of soap sink in the water, but that's not the case for ivory soap. Ivory soap floats because when it is mixed, tiny air bubbles are whipped inside of it, so that causes it to be less dense and float. This is going to be important later on. Now let's take the soap out of the water and set it aside. Now we're going to cut it with a knife into 4 pieces. If you look closely, you don't actually see the air pockets in the soap. Now, they're very tiny, but we know that they're there because that's how the soap floats in the water. Now, we're gonna take our 4 pieces and place them in the microwave. And we're gonna put it on high for 1 minute. Okay, now it's time to get them out. Whoa, as you can see, it looks like a puffy cloud. See? Ooh, kind of an interesting feeling. Surprisingly, this cloud-like structure isn't as soft as it looked. It's still rigid like a bar of soap. Whoa! Now, we're gonna go extreme. We're gonna do the experiment again, but we're gonna put 3 full bars into the microwave and turn it on 2 minutes. All right, let's check our extreme results. Whoa, that's crazy. It's got pockets of air in there. They're hot. But you can rip it apart like paper towels. All right, so what happened here? The air bubbles has water molecules in them due to water being a main component in the soap's composition. When this happens, the water molecules expand. At the same time, the heat causes the soap to be more pliable and can be pushed around by the expanding gas. Now, if we were to take a bar that didn't have the tiny air bubbles in there and it sunk in the water, it would probably just melt in the microwave. Wow, that was a crazy experiment. Bacteria and viruses, their other word for it is germs. Say that again, germs! Before we get started, let's dive in a bit about how soap and water react together to clean our hands. People have been using soap to clean their hands for about 4,500 years. Now that's probably a little bit different than the hand soap that you have in your kitchen nowadays, but it all works about the same. Soap, at its most basic level, is a fat or an oil base with an alkaline or metal solution added. When mixed together, we get a salt balloon with a fatty acid chain. It looks sort of like a balloon with a string, and the balloon is attracted to the water, and the fatty acid chain is attracted to the virus or the oil or dirt. When soap is mixed and created into a lather, it creates something called a micelle that traps the dirt and grime inside of it. It's important to wash your hands for at least 20 seconds so that way you can trap as much dirt and germs as possible before you rinse it down the drain. For this experiment, we need a basin of water, some hand soap, some biodegradable glitter, and some paper towels. First things first, let's get germy. Now, for this experiment, this glitter, this biodegradable glitter, is going to act like the bacteria, virus, and germs that we encounter in everyday life. So, in order to make it work better, we have to wet our hands first. So I'm going to wet this hand right here. And then I'm going to pour, ooh, some green glitter over here. Woohoo! And so, what we're gonna do, I got germs. Just kidding, no. So it's pretty much stuck on there. To show how people encounter viruses every day, we're gonna shake our own hand right now and see if it transfers off onto you. Uh-oh, got all on my hand on that side too. So now, we're gonna take some of our soap and we're gonna rub it together and create a lather really, really good. And we're gonna rinse our hands in this little basin. See if it comes off. And look, it's all clean. That's awesome. Remember that this happened because of the soap micelles that were formed whenever I lathered my hands up, and they got rid of the bacteria and viruses whenever I rinsed it away. While we have our materials out, let's discuss one more important reaction that soap has when mixed with water. I'm going to start with a fresh basin of water and pour some of my glitter on top. Like so. Okay. Then, what I'm going to do is take some of my soap, just a little bit here. And then what I'm going to do is I'm going to put it inside. Whoa! Did y'all see that? Did you see how the glitter just separated and went all to the side? Well, it did that because it broke the surface tension of the water. And that is pretty cool because it made the water even more wet, so that way it had the properties to be able to break the surface tension of the water. Pretty neat, huh? So why did this happen? Remember that soap actually breaks down the surface tension, which makes it so good to get into teeny tiny crevices whenever soap cleans. Since the water wanted to preserve the surface tension, it repelled itself away from the soap and took the glitter with it, which is great because now I want to go wash my hands. Thanks, guys.